By the name of God, the most merciful, most kind, peace be upon you, and God's blessing. This is Magid Kamel, and this is the third video, or post 3, the numerical linear analysis. The content of this video would be as follows: the illustration of how to get L and U decomposition for 2 by 2 matrix using Doolittle's method. Second point, how can we use elementary matrix to get L and U matrices? The third point, how can we solve 2 linear equations using LU decomposition? The last point is quick way to find x and y values for 2 simultaneous equations using L and U matrices. We'll move to the next slide then. We have A, the matrix 2 by 2. The elements are A sub 1, 1, 2, A sub 1, 2 equals 3, A sub 2, 1, 3, and A sub 2, 2 is 4. The quick reference for the L and U. We convert the matrix A into an upper matrix. We want that element to be 0, so we divide 3 by 2 and multiply by -1 for the first row and add to the second row. -3 over 2 multiplied by the first row plus R2, put it in R2, will lead us, this R1 will be the same 2 and 3, and -3 over 2 by 2 is -3, we add to R2, it will become 0, and -3 over 2 multiplied by 3 equals to -9 over 2, we add to 4, we have -1 over 2. As a rule of thumb, for the U matrix, we have A sub 1, 1 equal to U sub 1, 1, and A sub 1, 2 is the U sub 1, 2, and this element of course is 0 since we have an upper matrix, and the last element we have just obtained by trying to get the U matrix. What about the lower matrix? If we are using the Doolittle's method, we have the diagonal L11 and L sub 22 equals 1, and this element which is L sub 12 equal to 0, while L sub 21 is the value of the division of A21 divided by A11 without changing the sign. So it is 3 over 2. Here is the L. The minus of the 3 over 2, we use it before to get the U matrix elements values. We move to the next slide then. We want to make sure that the multiplication of the L by U will give us back our matrix A. So we have the L10 3 over 2, 1, and for U 2, 3, 0, minus 1 over 2. We multiply, we have 1 by 2 plus 0 equals to 2, 1 by 3 plus 0 equals to 3, and 3 over 2 multiplied by 2 equal to 3 plus 0, we have 3. 3 over 2 by 3 is 9 over 2, 4.5, minus 1/2, we get to 4. This is exactly matching with the elements of the matrix. We will move to the next slide. This is the same matrix, A, 2, 3, 3, 4. We want to use the elementary matrix to find the L and U. What are the values that we have obtained? L11, 1 and 1, and 3 over 2 for L21. U11 is equal to A sub 11, U12 equal to A sub 12. In order to get the U matrix, what we have done, that we have multiplied minus 3 over 2 by R1 and added to the second row. We put the result in the second row. If we use an elementary matrix, it would be composed of identity matrix multiplied by the minus 3 over 2 R1 plus R2. So we are going to multiply minus 3 over 2 by R1. So minus 3 over 2 by 1, and we add to 0. We get minus 1.5 or minus 3 over 2. And minus 3 over 2 by 0 add to 1. It will be 1. We'll find that the first row there is no change. So we have this elementary matrix. We call it E1. The elements are 1, 0, minus 1.5, and 1. We want to make sure that the multiplication of E1 by A is the required upper matrix. So we make double check. We have 1, 0 multiplied by 2, 3. Since this is a normal position, 1, 0 here, there is no change. The 2, 3 is also here. Minus 1.5 by 1 multiplied by 2 and 3, it will give us 0. And minus 1.5 by 3 plus 4 will give us minus 1 over 2. As we have obtained the upper matrix from the multiplication of E1A, we will write that equation U equal to E1, elementary 1, multiplied by A. If we multiply both sides by the inverse of this elementary matrix, so we have inverse of elementary matrix 1 multiplied by U, we will multiply the inverse of matrix E1 by A, because we are multiplying both sides. The inverse of E1 by the elementary matrix E1 equals to I, so it means that IA equals to the inverse of E1 multiplied by U. That will lead that the inverse of the elementary 1 is exactly the lower matrix L. And here is a reminder of how can we determine the inverse of a matrix of 2 by 2. If you want to have the inverse of matrix, say it is matrix B, we make swap of the 2 elements at the corner. So D will move here and the A will go down, and we change the signs of both 2 elements. Instead of B, it will become minus B, and instead of C, it will become minus C, and we are going to divide on the determined value of the original matrix, which is equal to AD minus BC. We divide. Then this is the expression for the inverse of a matrix. We call it B, for instance. We'll move to the next slide. After we multiply the inverse of matrix E1 by U, we have I equal multiplied by A, which will lead us to A. And since we have LU equal to A, and we have same U here, it means that the inverse of the elementary matrix 1 is exactly L. So L is the inverse of this matrix, which was 1, 1, 0, minus 1.5. And the inverse of this E1, again we swap 1 and 1, since they are both the same, there is no change. And we change the sign of minus 1.5 into plus 1.5. The determinant value is equal to 1, so we are going to divide by 1, no change. The lower matrix then it will be 1, 1, 0, and 1.5. This is the L, and this is the U values. And again, a reminder that for the Doolittle's method, we have L sub 1, 1, L sub 2, 2 equals 1. as we can see. We'll move to the next slide then. How we can get the x and y values for two set of equations, two simultaneous linear equations, by using the LU decomposition. There are two methods. One is long way to get the x and y values, and the other one is a shorter way. We will use the long way then. We are going to write in the form of ax equal to b, where a is 2, 3, and 3 and 4. This is the same matrix we have used so far. And x and y is a vector for unknowns, and b is the 13 and 18, which is a matrix 2 by 1. Consider that a is LU, and we are going to substitute a by x equal to b. We can write it as LUx equal to b. We take the multiplication of the upper matrix by x, we call it C. So we come to an expression mu1, which is L multiplied by C equal to b. If we multiply both sides by the inverse of L, so the inverse of L by C equals to the inverse of L multiplied by B. But since the inverse of L by L is the identity matrix, we will come to an expression that C equals to the inverse of L multiplied by B. As we know, the elementary matrix A1 was equal to the L, as we can see in the next slide. We have obtained the L matrix as 1, 0, 3 over 2, 1. We are going to get the swap of L minus 1 to get the value of the inverse of L, 1, 1, same, and here is minus 3 over 2 divided by 1. This is the inverse matrix L. We are going to multiply the inverse of matrix L by the vector B. This is the inverse of matrix L by B. 1, 0, minus 3 over 2 by 1, multiplied by 13, 18, to get the value of the matrix C. The value of the matrix C will be 1 by 13 plus 0 is 13, minus 3 over 2 by 13 plus 18, minus 39 divided by 2 is minus 19.5, plus 18 is minus 1.5. So we get the value of matrix C. But since C is equal to the U multiplied by X, we can use the inverse of C. So we can use the inverse of U we multiplied by C in order to get the X value, as we are going to see in the next slide. Since U multiplied by X equal to C, so we are going to multiply by U minus 1. U minus 1 U will give us directly the value of X and Y. So again, we are going to get the value of the inverse of U. This is U. So we are going to make a swap. Minus 1 over 2 goes up, and the 2 will go down. And we change the sign, it will become minus 3 and 0. We divide by the determined value, which is minus 1. Dividing by minus 1, same as multiplying. Minus 1 over minus 1. So the X value is U minus 1 multiplied by C. So X and Y will be minus 1 over 2 multiplied by 13 minus 3 multiplied by 1.5 is minus 4.5. So we have here 2. 0 by 13 plus 2 by 1.5 equal to 3. So we have again x and y is 2 and 3. This is a long way to get our solution. Next step is to make a final check of the values, whether it is correct or not for x and y. We have 2x plus 3y equal to 13 and 3x plus 4y equals 18. 2 by 2 plus 3 by 3, 4 plus 9 equal to 13. That is the right-hand side of the first equation. While for the second equation, 3 multiplied by 2 plus 4 multiplied by 3, we have 6 plus 12 equals to 18, which is matching with 18 on the right-hand side. This means that the x equal to 2 and y equal to 3 is the point of intersection of these two lines. The first way to get the x and y, again, we know that A is a multiplication of L by U. And AX equal to B, we are going to substitute LU multiplied by X is B. If we multiply from the left side by the inverse of L, like this, and from the outer side the inverse of U, and we take between brackets the inverse of L multiplied by L, we will get an identity matrix. Then again, the inverse of U multiplied by U is again identity matrix. We come to an expression that this is X. What about the right-hand side? We put the inverse of L multiplied by the inverse of U. So Ix from this expression equals to inverse of U multiplied by inverse of L multiplied by B. We'll move to the next slide. This is A matrix. In order to convert it into U, as we know, we have multiplied by minus 3 over 2 R1 plus R2. We use an identity matrix, and we get this U matrix as before. Minus 3 over 2 by 1 plus 0 is minus 1.5, and minus 3 over 2 by 0 plus R2 equals to 1. The first row, no change. The inverse of this elementary matrix, as we proved that this is equal to L. But this time we need the inverse of L. So the inverse of L is exactly the elementary matrix E1. If the inverse of E1 is L, then for L minus 1, or the inverse of L, it is exactly the elementary matrix. What we need? We need to estimate the inverse of U. We have U here, 230 minus 1 over 2. In order to get the inverse of this matrix, we will make swap. Minus 1 over 2 goes here, and the 2 goes down. We change the sign here, minus 3, and here it is 0, there is no change. Then we divide by the determinant value. The determinant value is 2 by minus 1 over 2 is minus 1. Minus 1 minus 0, so we divide by minus 1. For the next slide, we'll move. Apply the relation inverse of U by the inverse of L multiplied by B equals to the vector xy. This is U minus 1, 1 over 2, 3, 0, minus 2. And the inverse of L is 1, 0, minus 1.51. Then we will multiply. Both two matrices will be multiplied by matrix P, which is 13, 18. First, we are going to multiply the inverse of U by the inverse of L. So 1/2 by 1 plus 3 minus 1.5. This will give minus 4.5 plus 1 over 2 is minus 4. And for the next element, 1 over 2 multiplied by 0 plus 3, we have 3. And 0 multiplied by 1 minus 2 by minus 1.5 give us 3. 0 by 0 minus 2 will give us minus 2 here. Again, we will multiply by 13, 18. So we have minus 4 by 13 is minus 52 plus 36 plus 54 minus 52 plus 54 will give us 2. 3 multiplied by 13 minus 2 multiplied by 18 will give us 39 minus 36 equals to 3. This is the values of x and y. These values matches with the pre-estimated values of x and y using the matrix C. Thanks a lot and see you. Goodbye and take care.